Hi friends, welcome back to my channel. Let us try to solve one question which is related to lenses, that is refraction through a spherical surface. Question: lenses are constructed by material of a refractive index n is equal to 3 by 2. The magnitude of radii of curvature are 20 centimeter and 30 centimeter. Find the focal length of the possible lenses. Now what we should do actually? We should think of the types of lenses one can make. And here major unknown is the focal length. You should find out what is the focal length. Here one can think of, by using that problem, radii of curvature R1 and R2. Here R1 value 20, here also it is 20, 20, 20. R2 value 30 centimeter, 30 centimeter. So these are all in the centimeter range. So units also very important here. Centimeter. Now the possible ways one can construct a lens by considering the radii of curvature of the lenses are, these are the types of the lenses. One can take here R1 positive, here R2 negative, again R1 positive, R2 positive, again you can take R1 negative, R2 positive, R1 negative, R2 negative. There are 4 possible ways one can manufacture a lens. So what you are getting? These are the 4 possibilities. Now let us try to solve. Our duty to find out what is unknown. Here major unknown is the focal length. Focal length formula is given by, what you are getting, that focal length is given by the formula 1 by f is equal to 1 by f is equal to, here n 2 minus n1 divided by n1 into 1 by R1 minus 1 by R2. This is lens maker's formula. Lens maker's formula, where n2 is the refracting medium, n1 is the incident medium, R1 is first radius of curvature, R2 is second radius of curvature. Here what we are taking, the first lens. First lens we can take here, R1 is equal to plus 20 centimeter, R2 is equal to minus 30 centimeter. This is the first possibility. Here R1 is positive and R2 is negative. This is for a type of lens, it is convex lens. In case of convex lens, R1 is positive always and R2 is negative always. Always. So what we can take here, R1 is plus 20, R2 is minus 20. And if you draw the diagram, here what you are getting, in this case, it is the convex lens. Here you are getting, this is the first refracting surface, this is the second refracting surface. Light ray enters from air to glass. Air to glass. So you can take air is the first medium, that is N1 is equal to 1. Glass is the second medium, we can take N2 is N. And they have given the value of N, it is 3/2. So you can take here N is nothing but a 3/2. Okay. Now we have to substitute the value in lens maker's formula and we should simplify that. We should simplify that. Now what we will do? We will substitute the value of N1, N2, R1, R2 in the lens maker's formula. We will get that 1/f is equal to N2 is glass. So you can write immediately it is 3/2. N1 is the air. So you can write it is -1 whole divided by N multiplied by 1/R1 means you are getting it is 1/R1, R1 is plus 20 minus 1/R2 is minus 30. If you substitute here 1/f is equal to 3/2 minus 1 is the half multiplied by it is 1/20 plus 1/30. So immediately you can simplify here, you are getting it is half multiplied by, you can take here 20 into 30 means, you can take 20 into 30. 20 into 30 you are getting it is 2 into 6, 600. And here you are getting it is, here you can immediately write 2 into 30 is 60, so it becomes 2. 3 into 20 is 600. Okay, so what we are getting here, it is 1/30 or 20 into 30 600. Here you can write it is 20. Here you can write it is 60. So you are getting 30 plus 50. So immediately you can write it is half into 30 plus 20 means 50 divided by 600. 0, 0 gets cancels. It is 5/60. So you can write here 1/f is equal to 5/120. 5 you can write it is 6 into 60 into 2 means 120. 5/120 is nothing but you are getting it is 1/24. 24. So immediately you can write here 1/f is equal to 1/24. So you can write focal length is given by plus 24 centimeter. Okay, this is the type of lens, convex lens. So you can immediately write the focal length is given by plus 24 centimeter in first case. Okay, this is a type of lens, and here you are getting this type of lens is nothing but a convex lens. It is convex lens. Now let us see the second situation. Now let us look at the second case. In second case, R1 is a positive and R2 also positive. So what we will take, it is type B. Here N1 same, N1 is the air, so you are getting 1. N2 is the N. Then R1 already I told that it is plus 20 centimeter and R2 also it is plus 30 centimeter. These are the possibilities. Second possibility. Here what we can take, R1 20. R1 positive means curvature towards the right. and here somewhere you are getting the center of curvature, what we are calling it is a C1, and here you are getting it is R1. Same way, another curvature you are getting it is like that, and here you can take the same center of curvature, here it is a C2 and R2 here, R2. And this is the first refracting surface, this is the second refracting surface. It is a type of convex lens only, but it is concavo-convex lens. Concavo-convex lens. Convex lens. Because both radius of curvature are positive. Now let us write that focal length equation. 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. This is the lens maker's formula. Here we want to calculate the 1 by f. 1 by f is equal to n is 3 by 2 minus 1. 1 by r1, r1 is positive, r2 also positive. R1 is plus 20, R2 is the minus 30. If you simplify here, 1 by f is equal to 3 by 2 minus 1 means half multiplied by, here you are getting 600 LCM, and here you are getting it is 30 minus 20. So you can write immediately, it is nothing but half into 30 minus 20 is the 10 by 600. 10 by 600 means you are getting 0, 0 gets cancelled. Immediately you can write 1 by f is equal to 1 divided by 2 into 60. This is nothing but 1 by 120. So immediately you can write focal length of the lens is plus 120 centimeter. So here you are getting, in case of B, it is concavo-convex lens. So you can write B is a type concavo-convex. It is a converging lens only. Convex lens. Convex lens. Okay. Now let us move towards the type of a lens C. Let us look at the type of the lens what we can make by using these radius of curvatures, radii of curvature. Check the C. Here R1, first radius of curvature is minus 20 we can take. Second radius of curvature we can take it is plus 30. Plus 30. And all other features remain same, lens maker's formula same. Here n1 is equal to 1, n2 is equal to n, it is equal to 3 by 2. R1 is minus 20 centimeter, R2 is plus 30 centimeter. Okay. Now let us substitute the values in this expression. We can find out what type of lens we are taking. Let us try to analyze the radius of curvature first. Here R1 is negative. R1 is negative means the curvature should be towards the left. R2 positive means curvature should be towards the right. If you join these two, you are getting it is a concave lens. Concave lens. Concave lens is a diverging lens. And here you can write like this. C1, this is the first refracting surface, left side. Right side is the second refracting surface. Second refracting surface. Okay. Now, here C1, it is a C1, it is C2. From C1 to optic center, this is optic center. This is what you are getting R1. All the distances are measured from the optical center. Normally we will take the light direction from left to right. It is a light direction. Then R1 is the negative here. R1 minus 20 and here it is R2 we are getting plus 20, plus 30 centimeter, and it is a type of lens, concave lens, converging lens. Substitute here everything, you are getting 1 by f, n is 3 by 2 minus 1, 1 by r1 means 1 by minus 20 minus 1 by minus 30, minus 1 by plus 30, we have taken it is a plus, r2 is plus 30, r1 is minus 20. Substitute now, 1 by f is equal to 3 by 2 minus 1 means half, multiplied by, here you are getting in this case minus 1 by 20 plus 1 by 30. Now what I will make, actually it is 1 by f is equal to half multiplied by, here I will take minus outside, then it becomes 1 by 20 minus 1 by 30. Then you can write here 1 by f is equal to half into minus, here you can take again 600 LCM, and here you are getting it is 30 minus 20. 30 minus 20. So you can write here 1 by f is equal to half into minus, again 30 minus 20 is nothing but you are getting it is 10 divided by 600. Again it gets cancels. So you are getting here 1 by f is equal to, again here you can write it is minus 1 by f is equal to 1 by 120. 1 by 120 you are getting. Okay, you can write here R1 negative, R2 positive. So you can simplify here, it is minus we have taken outside. If you take the minus outside, it becomes, it is actually it becomes not, we have done mistake here. Actually it becomes minus, because here minus into minus into plus minus, and it becomes again it is minus 1 by 20 minus b, it is 30, 1 by 20 plus 1 by 30, again it becomes 30 plus 20, 30 plus 20 it becomes 50 what we are getting. Then again you can write it is 5 by 120 with the negative sign, 5 by 120 with the negative sign. Now look at the question very carefully, you are getting it is minus 1 by minus 120, so 3 by 2 minus 1 into 1 by minus 20 minus 1 by 30. Okay, so you are getting it is minus, if you remove outside 1 by 20 plus 1 by 30, take LCM, becomes 600, 30 plus 20 you are getting 5 by 60 into half with minus sign, this is minus 5 by 120, so you can write immediately it is minus 1 by 24. So you can write here 1 by f is equal to minus 1 by 24, so you can write immediately f is equal to minus 24 centimeter, and it is a type of lens, converging lens. Okay, so what a diverging lens, here you are getting it is a diverging lens. Okay, then you should remember here, it is in case of convex lens also we got plus 24, in case of concave lens we got minus 24. So you should remember, for convex lens focal length always positive, for concave lens focal length always negative. Okay, this is, we should remember that. Then now let us move towards the fourth type of the lens, what we can make by using these specifications. Okay, now let us check the fourth type of the lens, it is D. Here incident medium is air only, refracting medium glass as what we have used in earlier case, and n2 is the 3 by 2, n1 is 1. R1 what we will take, R1 is a minus 20 centimeter and R2 also minus 30 centimeter. Both are negative. Both are negative means curvature should be towards the left. So what you can take, here it is nothing but C1, here you are getting from here to here it is R1, so R1 is negative. Again R2 also negative like that, R2 also negative, and you can take here it is C2 and here you are getting it is R2, both R1 and R2. And it is a type of lens, it is convexo-concave. Convexo-concave. Both R values are negative. If both R values are negative, we can immediately think that is a type of lens, convexo-concave lens. Both R1 are positive, we will think it is a concave convex lens. And it is a type of diverging lens. It is a type of diverging lens. It is a type of diverging lens. Okay. Now let us substitute everything here. We wanted to find out the focal length. 1 by f is equal to n is 3 by 2 minus 1. It is 1 by r1. 1 by r1 is minus 1 by 20. 1 by minus 20 minus 1 by minus 30. Both are negative, R1 and R2. If you simplify here, 1 by f is equal to 3 by 2 minus 1 is half multiplied by, it is minus 1 by 20 plus 1 by 30. You are getting. Okay. Again, if you keep outside, it is half, it is minus outside, you are getting 1 by 20 minus 1 by 30. 1 by 30. Then again if you simplify, 1 by f is equal to half into minus, here again you are getting LCM 600, you are getting it is 30 minus 20. Then you can write it is 1 by f is equal to 1 by 2 multiplied by minus 600, 30 minus 20 is 10. Again the 1 cancels here. You are getting 1 by f is equal to 1 by 2 into minus 1 by 60. So you can write here 1 by f is equal to minus 1 by 120. Minus 1 by 120. So focal length you are getting f is equal to minus 120 centimeter. So this is focal length negative. So no doubt it is a diverging lens. The name of both R1 and R2 are negative. R1 and R2 are negative for diverging lens, and it is a type of lens convexo-concave lens. Convexo-concave lens. Okay. Now all the 4 types of lens what we can construct we have discussed. Let us go through the points once again. Okay. Let us now come to the conclusion. In the question they have given R1 as well as R2. They told that type of the lenses we can manufacture by using this glass. And refractive index already they have given, it is n is equal to 3 by 2. Okay. Now we can take type it is, first type it is A. R1 is equal to plus 20 centimeter, R2 is equal to minus 20 centimeter. And here what we can take, focal length what we got from the calculation, and type of a lens, type. And here what you are getting, these are the specifications, and here you are getting a type, it is R1, R2, focal length type of the lens. Okay, let us try to see one by one. A. Here R1 is positive and R2 is negative. This is for convex lens. In case of convex lens, here this is convex lens. Here R1, it is R2. It is first refracting surface, it is second refracting surface. It is possible in case of a convex lens. And focal length we got, if focal length is positive for convex lens, we got that focal length, it is plus 24 centimeter. This is first type of the lens. The second type of the lens, what I have taken, R1 is plus 20 centimeter. R2 is the, where it is 30 centimeter we got, okay. R2 we have taken 30 centimeter. It is minus 30 centimeter. And here R1 positive, R2 positive, both we will take positive. Okay. Then we got that focal length F is, it is plus 120 centimeter we got. That indicates that no doubt it is a convex lens, converging lens. Let us draw. R1 is positive, means curvature towards the right. And this is the here center of curvature, you are getting C1. And that distance what we are getting R1. Again, R2 also they told that it is like this. R2 also like this, curvature towards the right. And you can write there is a center of curvature, let it be C2. And that is R2. And it is a type of lens, and it is, first one is anyhow it is a convex lens. Second one also converging lens, but it is convex lens. Convex lens. And focal length are positive, both are converging lens, or type A and type B lenses are converging lens. Now let us go towards the next part. Here we have taken R1 is minus 20 centimeter, R2 is plus 30 centimeter. R2 is the plus 30 centimeter. And what we got here, this is nothing but, here we got focal length F is the minus 24 centimeter. Then R1 is negative. R1 is negative means curvature towards the right. And here you are getting it is C1, and here you are getting it is R1. R2 is positive means it is like this. Here you are getting it is C2. Here you are getting it is R2. Then if you join, it becomes a diverging lens. Focal length is positive for negative for diverging lens, and it is a type of lens, it is a concave lens. Okay, it is a concave lens. This is the third type what we got. Last type we have taken, both are negative. R1 is minus 20, R2 is also minus 30 centimeter. Okay, here focal length we got minus 120 centimeter. Minus 120 centimeter. Here minus 120 centimeter means both are negative, right? Both curvatures towards the left, like this. Left, here. And this is the first refracting surface. This is the second refracting surface. And both center of curvatures towards the left. R1 also towards the left. So it becomes convexo-concave. Convexo-concave. Convexo-concave means no doubt it is a diverging lens, because focal length is negative. Okay, so by using these two specifications, R1 is equal to 20 centimeter, R2 is equal to 30 centimeter, we can manufacture a lens. 4 lenses we can manufacture. One lens is completely biconvex lens. Another lens, it is concavo-convex. Next one, concave lens and convexo-concave lens. Only just by varying the signs of the radii of curvature. This is the question which is very important for competitive examination. Thanks for watching the video.